Okay, let's just jump right in. AI. It is everywhere, right? It's all over the news, it's on your phone, and it's supposedly changing, well, everything. But here's the thing. For a word we hear a million times a day, almost nobody can really tell you what it is. It's confusing, and honestly, there's a ton of hype.
Does this feel familiar? You hear things like machine learning, deep learning, neural networks, and it just feels like you're drowning in a sea of technical terms, doesn't it? They get thrown around constantly, and a lot of the time, they're not even used correctly. But don't worry, we are about to cut through all of that noise.
So what's the solution? Well, you need a clear map, and that's exactly what we're going to do. We're going to take a guided tour of the Staiblocks Introduction to AI course. It's actually based on the world-renowned elements of AI, and its whole purpose is to demystify this stuff for everyone. And the best part? No complicated math or programming required.
Okay, check this out, because this slide instantly clears up the biggest point of confusion out there. Just think of these concepts like Russian nesting dolls. The biggest doll, the one that holds everything else, that's artificial intelligence. Then you open it up, and tucked inside is machine learning, which is a specific way to achieve AI. And then inside that, you've got deep learning, an even more specialized technique that's really behind all of today's biggest breakthroughs.
So here's our roadmap for this tour. First, we'll introduce the course itself. Then we'll cover the absolute fundamentals of AI. We'll ask, what even is machine learning? Explore those cool-sounding neural networks, and finally, we'll look at the massive impact AI is having on all of our lives. All right, let's get started. Our first stop is all about the course's core mission, which is pretty simple: demystifying AI for absolutely everyone. And hey, you don't just have to take my word for it. This quote from Kunal Garg, a physicist who actually took the course, he just nails it. He says the terminology is scarier than the actual concepts. And that's so true. The jargon sounds intimidating, but the core ideas, they're surprisingly intuitive once you have a good guide.
Next up, let's rewind a bit and see how this all began. We're going to look at the fundamentals of AI. And you'll see this isn't some new fad. It's actually a dream that's been centuries in the making.
So that ancient dream really started taking shape in the 1940s with the brilliant Alan Turing. He laid the groundwork with this idea of computability, basically that anything that can be calculated can be automated. And this wasn't just theory. During World War II, these brand new machines were used to crack enemy codes, proving just how powerful they could be. Then, the whole field got its official name in 1956 when John McCarthy coined the term artificial intelligence.
And this is the crucial part. This quote from McCarthy became the field's North Star. Just let that sink in for a second. The sheer ambition in that sentence, written all the way back in 1956. It's this incredible, unproven belief that has fueled AI research ever since.
Okay, so that was the dream. But how does this stuff actually work today? Let's move on to the real engine of modern AI, machine learning. In other words, how machines learn from data. To really get this, let's start with a puzzle. How would you teach a computer to read messy, loopy, barely legible human handwriting? You know, the old way was to try and write a huge list of rules, like if there's a closed loop, it's a 0. But that approach is it's incredibly brittle. What even is a loop to a computer? It's a total dead end. So, instead of rules, we let the machine learn from examples. And this slide brilliantly illustrates the 3 main ways it does that. First up, supervised learning. This is basically like studying with flashcards. You give the machine thousands of handwritten numbers, and each one is labeled with the correct answer. Second, you've got unsupervised learning. This time the teacher leaves the room. You give the machine all the same data, but with no labels. Its job is to find hidden patterns all by itself. And third, there's reinforcement learning. Think of this as learning through trial and error, like an AI figuring out a video game by getting points for good moves and losing points for bad ones.
Now, this is really important. There is a golden rule you have to follow to avoid a massive trap. You always split your data. The training data, that's like the practice exam. It's what the model uses to study. But the test data is the final exam that you keep locked away. This is so important because it stops the model from just memorizing the answers instead of actually learning the concepts.
Okay, so now let's see how all this builds up to the tech behind today's most powerful AIs. We're talking about neural networks and deep learning, basically the brain of the AI.
The whole idea is inspired by our own brains. You know, a biological neuron listens for signals, and if they're strong enough, it fires off its own signal.
Well, its artificial counterpart does something pretty similar, but with numbers. It takes in a bunch of inputs, multiplies them by how important they are, those are the weights, and if the total score passes a certain threshold, it fires.
And here's the crucial point. It is inspiration, not imitation. This quote just nails it perfectly. We got the idea for airplanes by watching birds, but we didn't build planes with feathers that flap their wings, right? It's the same thing with AI. We're inspired by the brain's general principles, but we are not building a direct copy.
And that inspiration has led to some incredible specialized networks. You've got CNNs, which are like the eyes of AI, absolute masters at recognizing images. Then there are GANs, which are like the imagination. It's two AIs competing, a forger and a detective, to create brand new photorealistic images. And of course, there are LLMs, the voice of AI. Think of it as autocomplete on steroids, the tech behind tools like ChatGPT.
Okay, this technology is clearly powerful. So for our final section, let's look at the really big question. What does it all mean for us? It's time to talk about AI and society and its very real-world impact.
I'm sure you've seen a headline with a scary number just like this one. A famous Oxford study estimated that a whopping 47% of US jobs are at high risk of being automated. I mean, that's a number designed to make you sit up and pay attention.
But this is where the course gets really smart. It immediately warns us about what it calls the illusion of accuracy. A number like 47% sounds so scientific and final, right? But the crucial takeaway isn't the exact percentage. It's the trend that matters. The future of work is going to be much more about the things machines can't do: creativity, critical thinking, and complex human interaction.
And the challenges go way beyond just jobs. The course outlines a clear 4-point action plan for society. We have to tackle algorithmic bias, where AIs accidentally learn our worst prejudices from the data we feed them. We have to deal with AI-generated fakes, because the old saying, seeing is believing, well, that's over. We have to figure out how to guarantee privacy, and we must decide how to share the incredible benefits of this technology fairly, so it's not just for a small group of people.
And that's what this all leads to. Your adventure begins now. Because understanding these fundamentals isn't just some technical skill, it's a superpower. It empowers you. It gives you a seat at the table for what is probably one of the most important conversations of our time.
And really, that's the ultimate takeaway here. The future hasn't been written yet. AI isn't some tidal wave that's just going to wash over us. It's something that we are actively building, right now, together. So the only question left is, where are you going to let your curiosity take you next?